Let's start the recording for today's lesson. Okay, so today's lesson we're going to be covering is parallel lines and perpendicular lines in the coordinate plane. Okay, so we learned about parallel lines. Parallel lines are two lines that will never intersect, right? And perpendicular lines is kind of new. But perpendicular lines are just, I'll explain it in the next slide. So here we're going to be using parallel lines and perpendicular lines in the coordinate plane. We worked with this before, slope intercepts, or working with slope before, and we're going to be using those slopes in a coordinate plane to determine if the two lines we're going to be comparing are parallel or perpendicular. Okay. So first off, we're going to be focusing on the slope intercept form. Is the formula of y equals mx plus b. This is kind of, a lot of you are probably familiar with this, but some of you are probably not. But I'm only going to focus on the geometric aspect. So the two things you're going to be focusing on the most is the letter m. Okay, because m, we're going to be talking about, again, we're going to be talking about the slopes, and we're going to be using those slopes to determine if the two pairs of slopes are parallel or are they perpendicular. Okay, we're not going to be focusing on this too much, but if you want to focus on it, then you can do that on your own. So that's pretty much it. We're only going to be focusing on the m aspect, which is the slope part, and the slope part is the y-intercept. Going on to the parallel. So parallel lines in a coordinate plane. How does that look like? Parallel lines in a coordinate plane is both slopes are the same. What does that mean? So to determine if they are parallel lines, both the slopes in each of the equation of line 1 and line 2 are going to be the same. So here, if we're looking at example number 1, here we're going to be talking about, we're only going to be looking at -3 and -3. Right? So we're going to be looking at -3 and -3. Then what we can do is we compare these two, right? Are they the same or are they not? A lot of you would say that they are exactly the same. Yes, because the first slope here is -3. Let me try to zoom in. The first slope here is -3, and the other slope here is -3. Okay. So once you do that, then you determine that these two slopes are parallel. Yeah. Because why? Both slopes are the same. Okay, that's pretty much it. Let's just try it out, right? So now there's 4 slopes on the right. I want you to try it, right? Which slopes are parallel? The answer for this one is A and B. That is the correct answer. Why? Because here, once again, you're just looking at the slopes. Here the slope is 2 over 5, and here this is not 2 over 5. So once again, we're looking at both slopes that are the same. 2 over 5, 5 over 2 is not the same as 2 over 5. 4 is exactly not over 2 over 5, but that should have been a choice. 2 over 5, and here the slope here is 2 over 5. How do you know you're looking at the slopes here? Once again, you're looking at the slope intercept form, which is y equals mx plus b. To find the slope is always you're looking at the number that's right next to the variable of x. Okay. So here, once again, I'm looking at 2 over 5 at letter A, and I'm looking at letter D, which is also 2 over 5x. There's no number here. If you don't see a number here, then it's okay. You can always watch the snaps. I'm still recording. So here you don't see any y-intercept on the right. It's always an invisible. It's always a 0. But in actuality, you don't have to write the 0 because it's kind of redundant, right? Like you already know it's 0 because what number else could it be? It's not really necessary for you to write 0 because it looks a lot cleaner saying just writing this way. But if you want to put a 0, then to understand it a lot better, then you can do that as well. Let's graph that now. I'm going to stop showing this. So remember this answer, 2 over 5x plus 2 and 2 over 5. I'm going to graph that just so we could see that. So what I'm going to do is I'm going to graph by parallel lines and perpendicular lines. You're going to be doing this for a part of your assignment. So you just click an X here. I'm going to close it here, and I'm going to type down the formula of y equals 2 over 5 x. Oops, sorry about that. 2 over 5x plus 2. Okay, so that's the first graph here on the right, and I'm going to write down the second graph, which is just y equals 2 over 5x, right? That's it here. Let me kind of make it bigger. I wonder how that looks like. It's, oh, snaps, you don't see it. Hold on. Stop sharing it. So I'm going to go to the page of the link here. Does everyone see that? Not yet. Hold on. There you go. So you see the slope intercept. Well, how they did this was all I did was just type it down here. Okay. If I want to close it, I just close this and the slope disappears. But if I want to add it, I just click on this expression again and put y equals 2 over 5 and put x, then put a plus 2. But before we do that, let's study this one here. Okay. The slope here is 2 over 5. Yes, we're using decimals. We're using 2 over 5. Here it passes through once again. It doesn't have to say 0, but here it's, you just type on 0 and it will pass through that. This slope will pass through the y-intercept of 0. If you start at this point, what you're going to be doing is you're going to be rising 2 times up and you're going to run 5 times forward, right? So let's just count that, right? I'll be starting from here. I'll be 1, 2, and then once you go here, you go 5 times forward. It'll be 1, 2, 3, 4, 5, and you reach this new point here, right? And you can keep doing that over and over. And I just want to show a little explanation. So here, the next one on the left side, I'm going to put the 2, and it's going to pass by the y-intercept of 2 here. Okay, so I'm going to put a 2 here, and right here, the slope of 2 over 5 passes through the y-intercept of 2 here. Here you can change it. You can change this to 3, and it's gonna go. It's gonna the slope should pass by the y-intercept to 3. You can change it to even 1, and it'll still go. The y-intercept changes, right, based on what number is given after the slope. You can also even give it 7. You don't see it right now, whoa, but if you put 7, it's gonna pass by the number 7. So I just wanted to share that just so you have an idea of how y-intercept works. I don't want to teach it because I feel like we're going to spend too much time. I'll give you the idea of it. Okay. So since it's 2 over 5x plus 2, it passes through the y-intercept of 2 with the slope of 2 over 5. Rise up 2 times and run 5 times forward. 1, 2, 3, 4, 5. Okay. And here you can see here, the point about this is we're trying to determine if the 2 lines are parallel. Our example is all parallel lines. If we zoom out, what's happening, no matter how far we go, right? Are the 2 lines crossing? No, it's not, right? So that's one way to determine parallel lines, right? Through a graph. Parallel lines again, sorry. So parallel lines, once again, 2 lines that are not intersecting. I'm gonna give you the second example or third example. Another form of parallel lines is when you have horizontal lines like y equals 5 and y equals 3, right? Or you can also have x equals -3 and x equals 4. What does this mean? I'll show you it. I'll show you that in the diagram. So first, we're gonna diagram. First slopes we're gonna be drawing is y equals 5 and y equals 3. We're gonna go back to the Desmos. Sorry, I'm just giving you more examples of what parallel lines are in a graph. Okay, so once again, I'm going to just type down y equals 5, and that's going to give me a horizontal line. Whenever you see y equals 5, it's an horizontal line that passes through the y-intercept of 5. I'm going to add another expression here, and I'm going to add y equals 3. Okay, and here it shows that a black line here. Maybe I'll add one more just in case. Y equals 3. There you go. I'll put this as a 0. So there, you see a purple line and a green, a red line. So here you have the two lines here, and if you zoom out more, what do you notice about the two lines? They are not crossing, right? A lot of the parallel lines we see is like from buildings, right? Books, television, everything basically that two lines are not touching. And you kind of learned that in lesson 3-2. And we're gonna do the other example next. We're gonna do x equals -3. And we're gonna do the next slope is x equals 4. Once again, you see here x equals -3 and x equals 4. If you zoom out, right, what's happening to the two slopes? They're not crossing, right? They're parallel. So that's the way you can determine parallel lines in a coordinate plane. One is vertical lines, the other one is horizontal lines as well.